Hello everyone, this is Ashika. Now I am going to present about the analysis of credit risk using the Power BI tool. So first, let's understand what are the key columns that this credit risk dataset is having. Here you can see it is having the information about the personal age, person's income, home ownership, person employment length is nothing but the experience that person is having in the field, the work starting from 0 to 123 is the experience, the information it is having, and also the loan intent, the what purpose the individual has taken the loan grade, and also the loan amount, loan interest rate, loan status like 0 and 1. It means 0 means they are the non-defaulters, where 1 means they are the defaulters. Okay, that kind of information, loan percent income, and like person's credit history length, person employment length, this kind of, and this kind of information this data set is having. Let's see what are the tasks that we need to do in this presentation. That is, we will calculate the average loan amount, interest rate according to the loan grade, that will correlate with the loan default rates, and also we will visualize the loan status distribution, like defaulters and non-defaulters, according to the home ownership kind and his employment length, and segment the borrowers according to the loan to income ratio, and also we will analyze the trend of loan default rates, how it will going to vary according to the person's credit history, and also like we will perform the what if analysis, like situation based analysis and geographical analysis, and we will calculate the risk score. So that kind of analysis that we will do in this presentation. The first task is, we need to calculate the loan default rate according to the loan grade. Okay, for that, the loan default rate, the simple formula for loan default rate is total number of default loans divided by total number of loans. Okay, total number of default loans will be calculated like a count of rows in the credit risk dataset table, like wherever the loan status column is equal to 1, it means 1 means they are the defaulters. Okay, that column rows only should calculate, that is the formula this says. And also the count rows of credit risk dataset, all the rows in the credit risk dataset, it gives the total number of loans. So that figure you should divide, that is the formula for the loan default rate. And also the average interest rate formula, that is, I want to average the column of loan amount in the credit risk data set. Similarly for the loan interest rate, so the results that I got as loan grade, average loan amount, average interest rate, and the loan default rate. Here you can see as average loan amount increases, average interest rate is also increases, and loan default rate is also increases. It means the existence of positive relationship or correlation between the average loan amount and the loan default rate, and average interest rate and the loan default rate. Okay, and also I have plotted the column graph. Here the vertical bars, they represents the average loan amount across the loan grid, and this trend line per blue color trend represent the loan default rate across the loan grid. Here the loan grade G records the highest average loan amount, followed by grade F and E. Okay, and also the loan default percentage increases progressively from okay, loan default percentage is increases progressively from uh, loan grade G to A. Okay, higher the loan grades like EFGs not only have a larger average loan amount, but also have a higher interest rate and higher default rate. It means there existence of positive relationship between leverage loan amount, a loan grade, and also the default rate, nothing but the default risk and the interest rate. Okay, so therefore lower grades like G represent the higher risk lending segment, while higher quality grades like A and B are the low risk with a small loan amount and also low interest rate. This conclusion that we can draw from this graph. Next task is to analyze the distribution of loan status, that is defaulters and non-defaulters across employment length and home ownership. So here I have plotted the person employment length across x-axis, y-axis count of loans is nothing but number of loans. For legend, I have taken the loan status. Nothing but the yellow color which represent the defaulters. Okay, zero, that is maroon color, represent the non-defaulters. Here you can see, as the person employment length increases, the number of loan applicants also decreases, gradually decreases, and also the loan defaulters also decreases. It means as person employment length increases, their experience got increased, so their salary will be better and their income will be stable, and they are convert to the defaulters, non-defaulters from the defaulters. That exactly we can observe from this graph. And also we could see the distribution of loan status across home ownership, like rent and the mortgage and the own. Okay, the rent and mortgage individuals is having higher application to the loans compared to the individual those who are in the own house. Okay, and also the defaulters is also more in case of rent and mortgage compared to the own. So it means the individual those who are in the own house, their income is, they are having a better income background, so therefore they are less applied to the loan, they dependent on the loan amount. And also they are the defaulter, they are the non defaulters, they are not a defaulters. Okay, compared to the rent and the mortgage. Among the rent and mortgage, those who are in the rent, they are having highest loan applicants and also the defaulters. And also the next task is we need to analyze loan to income ratio. It means loan to income ratio, that is average loan amount and average income. Hmm? And here I have plotted the bar graph to for the loan to income ratio across the purpose, like what are the intention, the purpose, the individuals those who have taken the loan for what purpose, that purpose versus loan to income ratio. This what exactly this loan to income ratio says, it like how much loan a borrower has taken compared to their annual income, like it shows the borrower repayment capacity. Okay, here the those individuals who has taken the loan for the medical purpose, those loan to income ratio is high compared to the other purpose, like and also the loan to income ratio is low in case of the home improvement. Okay, it means always we will expect to this figure to be less. Okay, lesser the loan to income ratio, it means lower risk and better repayment capacity. Moderate means they have medium risk, but this loan to income ratio is high means there is a high risk and higher probability of default. That exactly this ratio says. Those individuals like taken loan for the medical and educations, they're having higher repayment burden on the borrowers. And a personal loan shows a moderate loan to income ratio, it means balancing loan size and also the borrower's income. Okay, overall loan intent like influences the borrower's behavior, and they have a financial risk. Okay, with medical and education loans have posing a relatively higher income pressure on the borrowers compared to the home improvement and the personal loans. And this is graph shows the trends of loan default rate, how the loan default rate vary according to the person's credit history. Here you can see, as the loan default rate is remains stable up to the certain, like certain credit history length of a person, up to the middle credit history of person's credit history. At the mid, like around 20 credit history length of a person, this loan default rate shows a higher trend, increasing trend. Again it shows a spike, a default percentage at the higher credit history bins. It means the potential over borrowers are accumulated the credit risk among the long tenure borrowers. Okay, and also we could observe the strong sudden drop after the peak. It means volatility in the default rates at the extreme credit history lengths. So overall we could conclude that there existence of non-linear relationship between the loan default rate and also the credit person's credit history. And also next task is to, we need to do the what if analysis, nothing but the situation based analysis, like if there is a changes in the changes, it means there is an increase or decrease in the interest rate, what its impact on the loan default rate and adjusted interest rate, that we need to analyze in this. Here in Power BI dashboard only we could see clearly. 1 minute. Okay. Here, if interest rate changes from 1 to 2, accordingly the adjusted interest rate changes and simulated default rate changes. Here you can see. So this is exactly what if analysis will do. Here, if the person's if the interest rate loan interest rate changes from 0.5% to 1%, the adjusted interest rate changes from 11.51 to 12.01, but the simulated default rate is remains same across the both the interest rate. It means we conclude that there is a small or slight changes in the interest rate does not have a impact significant impact on the default rate, simulated default rate. Okay, it means in the short run, but in the long term it's having a impact. So that conclusion we can could draw from this analysis. And next task is to we need to analyze the risk score. For that I have used this DAX measure. Here I have calculated loan grade, loan default percentage, risk score and risk category. Here you can see loan grade A and B, they fall under the risk score of 4. They have fall under risk medium risk category. Whereas remaining all the grades, they are having the risk highest risk score. They fall under highest risk. It means a loan, it means let us say from grade C onwards, there is risk score jumps to 7, reflecting sharp increase in the credit risk. So loan grade C to G consistently fall under higher risk category with default rate rising from 21% to 98%. Okay, the strong alignment between higher loan grades and the higher risk score validate the risk scenario framework, that thing. And also the this model effectively distinguish safer loans from the riskier ones, so aiding the credit screening. That the kind of thing that we could observe, that like it helps in the credit screening, how well this risk from medium risk to high risk, how we can distinguish easily safer loans from the riskier ones. Okay, and also the clustering of higher risk score for a lower grade suggests a need for a strict monitoring or the higher interest premiums. Okay, and also medium risk loans like grade A and grade B may be suitable for selective approval with the safeguards. Okay, and next is the geographic data exploration. Like if we in the data set, credit risk data set, we don't have any information about like geographic variables like state or city. If it is available, we could done this geographical data exploration. Like we will use the filled maps like reason default rates, reason wise default rate, we could check that. And also the bubble map we could use for to represent the loan concentration. Heat map also we could use to compare the reasons against the loan grades and also the risk categories. And also we will analyze the to help to identify the high risk reasons with the loan concentration and spatial default trends. That kind of analysis we could do. And also the row level security. This row level security, it means uh, the row level security which restrict the data access for the specific users. Like it ensures the users can see only the data that they have allowed to see. For example, south manager should see only the south region data, like north manager should see only the north region data. That kind of security that we want means we will implement this row level security in the Power BI. Okay, like dynamic row level security, like based on the logged in the users, like user principals name, and also the this kind of dynamic row level security also will do. And also the static row level security, like fixed filters, like if the reason is only south, if reason is equal to south, that kind of analysis. So this is the how we will do this row level security. So after defining the roles in the desktop, we will assign the users in the Power BI service. So thank you. And also one more, we have an interactive dashboard at last. Like how here I have used this cards to like cards that I have used to see sum of loan amount, average interest rate, loan default rate, and risk score overall. For overall data set it is having. And also I have used the sizes like loan grade, person's home ownership, and person's employment length. And also I have plotted this pie chart to show the loan status, like defaulters and non-defaulters. Like defaulters are the non-defaulters are more compared to the defaulters across the loan distribution. And also the average loan amount, default rate, that I have already shown in the last slides. This is exactly how we will do. If we want to see only for the loan grade A, accordingly data has changes, and loan grade C I want only for the people those who are in the mortgage, that kind of analysis. Only the person employment is between 2 years. So this kind of exact filtering that we could do with the help of this interactive dashboard. Okay, thank you.